With the fear of adding a little bit of delay, let me add a little bit of an introduction. Thank you very much for the invitation, both to Stefanos, Nikos, and the entire core personnel. And I like very much my position within the program because it's well after lunch, so you're already full. And it's well after Nikos' presentation, which for me was very much impressive. And also, I believe it's a logical sequence with the previous presentation, which I believe you will find at least some common words, if not some common graphics as well. Okay, so it's a tough audience to present because you're all experts in the field that all of us are presenting. And it's a little bit more harder for me because some of my colleagues are here, so I have to make sure that I will represent their work in a more effective way. By saying this, let me also thank Kostas Nasko, who has helped me a lot, my colleague, to prepare this presentation. Most of what you will be hearing, it's also part of his work. Okay, so I'm here to present you our team's vision about Operator 5.0 and how different technologies come together in order to reshape human-machine collaboration in the shop floor. And we're trying with that vision to actually put the human back in the center of industrial innovation at the shop floor, not just as a simple executor of machine tasks, but actually as an orchestrator of collaboration. And we have all the different tool sets that we're trying to use about how this will be done, name it extended reality, digital twins, wearables, digital twins of both humans and assets, but also machine learning and artificial intelligence. So I'll skip all of that. You are very well aware of the Industrial Revolution. I will once more use that scheme just to emphasize that although we're speaking about Industry 5.0, it might be Industry 4.0 on steroids. I like very much, and I stick to the Commission vision, that the tendency is about more human centricity, resilience, and sustainability. So we're moving from automation-centric to human-centric collaboration, from efficiency to sustainability, from optimization to human and machine co-creation. And these are the keywords that I will try to highlight throughout my presentation. So at the end, if I don't manage, please say so. Okay, so where does the human lie within the whole landscape? The human is no more a passive node in the industrial line. He's an analytical thinker. He's in the epicenter of everything. He's a node of collaboration, a node of communication. He's able to receive and transmit all kinds of useful information to whatever deems useful in its surrounding and in its work environment. He's aware of everything. And to do that, he's supported by a variety of technologies. So it can be, for example, XR, either from headsets or AR projection for guidance. It can be from artificial intelligence for informed decision-making. It can be for digital twins for elevated simulation. It can be wearables that guarantee safety and ergonomics. It can be reinforcement learning in order to refine human skills in a digital way. Or, of course, it can be robotics in order to have common workflows, sharing workflows of heavier and repetitive tasks. I'm trying to give you some illustrations. I don't have Nikos' presentation with a nice graphics, but I did include some videos in order to wake up a little bit the audience or to make it more appealing. These are quite well-known implementations of immersive guidance on the workplace itself, either using a helmet on the left-hand side in order to provide visual cues directly on the visual field of view of the operator, or if you don't want to wear a bulky or not so bulky HMD anymore, you can have directly AR mapping and AR instructions, let's say for an assembly task directly on your workspace, which is, I have seen similar implementation, for example, 10 years ago from Nikos Frangakis, and this works out very well, especially if it is on a confined workspace, a fixed workspace, and repetitive tasks. Digital twins are becoming more and more emerging, not as emerging as I would hope they would be, but at least because I believe Nikos again was talking about silos. I believe these silos prevent us from a large implementation of digital twins in larger processes, but digital twins are a perfect example that exploit the full potential of extended reality. So they help us. They help the operator, they help us transform the actual environment to a virtual test bed where we can test different simulations, different variations, measure the outcomes, and all that in a safety environment before actually having to test it on a real environment. And this can happen in all different, it can be scaled up, it can start on a device level, it can go up to a floor, to a shop floor level, or it can go up to a city level. So you can change, you can test alternative variations, you can tweak parameters, and you can all at the same time do elevated simulations. Okay, I'm sorting it down to where operator 5.0, which is the use case that we are mostly interested in. Our team is working quite a lot on material sorting, especially for user recycling purposes. And this is usually being handled in large conveyor picking lines, and there is some manual work already in place where usually people are asked to have some kind of familiarization with the materials that they are sorting. However, the studies show that for this task, usually either new or rotating personnel is being used, which means that the use case itself leaves quite a vast place for technologists to step in and help guide those people in order to make their job more effectively. And I will have some videos about how we propose to do that at the end. At the same time, it is a process where you can, if you can actually manage to monitor and record it, then you're able, by processing the data, to streamline it by, I would say, a significant percentage. A subset of that technology that we are particularly interested in is textile manipulation. So you might have seen, some of you, some robots that are being used in order to fold different pieces of garment, especially in laundry context. We're interested in exactly the opposite way. So we're trying to unfold the garments in order to scan them and redirect them to reuse or recycling paths, or to take out specific external components like buttons or zippers that can contaminate our downstream flows. And it's, the task requires dexterity, it requires precision, perception, and the precise also collaboration between human and robots. So it makes a perfect landscape for our operator 5.0 to come in place, because the human operator himself can bring finesse and intelligence, while the robot itself can bring consistency and endurance. And how do we keep the human in the loop of communication? First, we try to guide him either through XR or other technologies about how to perform his or her task. Then we monitor the way he performs, his posture, his mental walkthrough, and then we input that to our simulation environment in order to use that as a training for our robots, which, as they become smarter and smarter, are able to reshape the entire flow, involving also the human in a more effective workflow. And all that by ensuring that safety and ergonomics are in place. Okay, and so how we start to imitate human behavior, first of all, either through headsets or whatever kind of other sensors, we try to grasp the way the people are working. We input that to our simulation environment and try to mimic that. And then we start tweaking, for example, the different trajectories, different pathways, or different speeds, variations of speeds. And then we augment the environment itself, the simulation environment, by changing the lighting conditions, or changing the clutter, or changing even the texture and color of the different materials that we have to handle in order to make our model more robust. And of course, the big challenge is how you bring, again, the knowledge from the simulation to the actual reality. And to do that, we use, for many times, human in the loop feedback in order to bridge that gap and create a shared mindset where the operator teaches, the machine learns, and they all together plan a more effective workflow. So this is one of my colleagues that is working around an industrial facility close to Athens in Koropi that is trying to perform imitation learning using a robot framework on a simple robot by folding a piece of garment. It's not an easy process, but then we want to expand to richer foundation frameworks in order to actually change to more complex tasks and our operational robots. And we use this scalable approach in order to decrease the risk and try to ensure that whatever we experiment with in our lab environment tries to map in the actual shop floor. I told you that we're using XR in order to guide, let's say, rookie operators. And we're doing that by experimenting different modalities. For example, backlit conveyors that help us provide visual cues beneath the conveyor line, an annotated video wall that can provide textual information, but also some AR projection exactly on the workspace that can provide high-end instructions. And last but not least, about building our human digital twins. we are starting again with lightweight real-time framework for pose estimation, and then we're moving to more advanced foundation models and 3D segmentation in order to do motion prediction, generation, and simulation. And we're also grasping cognitive-related information by using, for example, eye tracking in order to gather attributes related to attention, fatigue, and information overload. Okay, so I believe I said a lot of things in just such a short period of time. I just want to leave you with one message. Our vision of Operator 5.0 is not here to replace people, it's here to empower them and make them the center of human-machine collaboration. And by following this human-centric approach, I believe that the whole process can be streamlined, can be more efficient, and the end result can be of better quality, and I would say more sustainable product. And this kind of human centricity is what I believe Industry 5.0 is trying to point us to, and also our research group is working towards that direction. Thank you very much.
Quite impressive technologies, I would say. Any question from the audience? Okay, if not, I will ask you something, because you know, we saw a lot of technologies that we're discussing the last years with XR and the whole human-in-the-loop process, which, okay, it's quite encouraging also for in this era that we are, and the technologies that we're discussing. How far are we that, you know, the industry adopts some of them in a larger scale, I would say?
One would start, if the technology is ready, I believe we're past that answer. The second point would be if the personnel is ready. We're not past that point, but I believe we're getting there. But what we're not getting there is, I believe, organizational culture. Especially traditional companies and manufacturing companies are quite traditional, are quite sticky to entrenched processes, and are quite reluctant in order to reshape the entire workflows, at least in a massive scale. And I believe if we manage to persuade them step by step, then the others will follow. And one way or another, we have to adapt to the technology pace.
Okay, thank you. I think demonstration then it's very important for, in order for them to see before they buy.
You are most welcomed in Koropi to see us. Thank you.
Thank you.